We're going to try to understand general graph relationships in this video so that we can use them to analyze kinematics graphs and in later units, other types of graphs. So the purpose of a graph is to determine the relationship between any two variables if there is one. And that's all we're really looking for. And in order to find a relationship, we're looking for a trend. So what direction is it changing? What direction is a trend developing? You know, we don't just want to say when one thing increases, the other increases. We want to know how it increases. We want to know, that it's increasing as a direct square relationship. We want to know, how does it change? Does it increase quickly or slowly? How slowly, how quickly? So that's why we need to talk about this more than you might have done in the past. A trend line is the shape or form of typical graphs. So we call that a best fit line as well. So we're going to talk about a bunch of them. Linear relationships are the ones you're most familiar with. You start learning this when you're in middle school, right? Straight line relationships are the most common, right? Where they have a constant slope and the form is y equals the slope times x. Inverse relationships show this shape, right? Where there's two asymptotes generally. When one goes up, the other goes down by a constant factor generally, right? Here's this coefficient. You can write it as x to the -1, or you'll also see it as 1 over x. A direct square relationship is also direct when x increases, y increases, but it does so as a square relationship. So you'll see it as some coefficient times x squared, as opposed to just x by itself. Inverse square relationships are similar to an inverse relationship, but again, in the denominator, instead of just the variable x, you'll have x squared. So this is 1 over x squared. So in physics, these are pretty common relationships. Square root relationships come up occasionally. It's x to the half power. That means square root. But you can also have some experiments where there is no relationship. It can be a couple different ways, right? You can have a vertical line where x equals something. You can have a horizontal line, that's the most common, where you change x and there's no change to y at all. It always stays pretty much the same. Or you could just have like a random assortment. It could be any of those. So how do you evaluate whether the trend line you choose is any good, right? So there's two ways to do that. First, you want to look and see what's the theory. When you look at your equation sheet and you look at the current unit you're working with, if you find the relationship that has the variables that's on your graph, it'll show you what the trend should be, theoretically. And then you can see if it fits, right? So if it's a linear relationship, try a straight line. If it's a squared relationship, then try a power fit or polynomial fit. So you can choose that way. That's my preferred way to do it. The other thing that also is very helpful is the correlation coefficient. So when you use Excel, you can check the box for your trend line that shows display the correlation coefficient. And what it does is it tells you how close your data is to the trend line you've chosen. So if it's really good, then it's probably the right trend line. Now, sometimes you'll get a bunch of right ones, and then you have to figure out which one is best to use, and it isn't always the one that's the highest, because it's experimental data. So then you have to do a combination of these two things. So this list of 4 items I took right from AP Physics resources. And I want to read these through because these are what they perceive as the most common errors when you do graphing. And I want you to avoid them at all costs. So one is that most of you don't understand that when you say graph A versus B, that A goes on the y-axis and B goes on the x, period. That's how we name graphs. Most of you think that when you're getting the slope, you're allowed to use 1 point. You may not. It's always any 2 points on that trend line you can use. If one of them happens to be 0, show it when you're calculating your slope. A lot of times you don't realize that the slope itself has units. It has the units of the x and y axis, y units over x units. And how to find area under a curve, right, is to use the shape, and I'll show you that in another context. If it's a rectangle, then you use base times height. If it's a triangle, then you can use 1/2 base times height. And the units are the units of the product of those two axes, again. So these are things that we're going to talk about over and over. If one of these really, you do and you're not quite sure how to fix it, please come see me. So I want to just spend a second talking about trend lines in Excel again. Excel has these choices, right? There's always these six choices when you go onto Excel. Listen, we never have anything in this class about logarithmic. We never do exponential, and we never use moving average. Logarithmic, there are logarithmic physics relationships, but we're not going to do them in AP1 or in CP. So don't worry about ever choosing that one. Exponential means e to the x. It does not mean a number with an exponent. It doesn't mean x to the n. That is polynomial, right? So we don't want exponential. We don't have any physics relationships that are e to the something. So your choices are going to be linear, polynomial, or power. The exponent of a power fit equation, it tells you what the exponent on x is. So it's kind of interesting because if it's linear, you're going to have something close to +1. If it's inverse, it's to the -1, right? This is x to the -1 power. This will be x to the +2, x to the -2, right? So you're taking, that's what power fits will tell you. Now, if it's an experiment, it's not going to be perfect, right? So you might have x to the -0.92 or x to the -1.02, like that. That's fine, right? We're going to round them so that you can see what's it close to. This is an advanced concept, linearization. Linearization is how to make a linear graph of a nonlinear function. And in CP, we don't do this at all, but for AP, you're going to need to be able to do this. This comes in really handy when you're doing graphing by hand, and you need to know the slope, but you can't find the slope of something like this because you won't have access to Excel. So if you have a graph like this that is a quadratic graph, you can linearize it, make it into a straight line graph by graphing distance versus time squared instead, right? As opposed to this being distance versus just time, right? And you get a curve. This is distance, and on this axis is time squared. So I will be showing you how to do that in more detail in a different context, but I want you to know that you can do that. It's not actually hard. You just make another column in your data table and do the function. So if it's x to the, and you see that this is to the -1, right, then you're actually going to just graph x to the -1, and it'll give you a straight line function that you can then evaluate more easily. This chart I found online. This was great, in my opinion, because it shows if you get this graph shape, then you can plot what can you do to get a linear, to linearize it. So you can, this is something that you may want to jot down.